Section 6.3, example 3 says, solving graphically a problem with continuous positive variables. So you're going to learn a little bit about sailing today. A sloop is a sailboat with two sails, a mainsail and a jib. When a sail is fully out or up, it is said to be out 100%. That makes sense. When the winds are high, sailors often reef or pull in the sails to be less than their full capability. Otherwise, they might get blown away or blown into the Bermuda Triangle or something. So Jim is out sailing in winds of 22 knots, which are relatively high. So he wants no more than 80% of the mainsail out. So he's going to reef some of the sail in. So let's take a look at that again. No more than 80% of the mainsail out. That's going to be important. He also wants more mainsail out than jib. The question is asking us what possible combinations of mainsail and jib can Jim have out? Step one, variables. We're talking about M for mainsail or percent of the mainsail. And J is the percent of the jib. Step two is our restrictions. Now in this case, we can have any possible value of percent above 0, but we never really ever talk about percent below 0. So what we're going to do for this is we're going to say that M has to be greater than or equal to 0, and M can be an element of the real number system. We can say that with the jib as well. Jib has to be greater than or equal to 0, and jib is going to be an element of the real number system. Move on now. We can create our inequalities. The first one says no more than 80% of the mainsail is going to be out. So what we can say for that is that M has to be less than or equal to 80. No more than 80%. It can be equal to 80, but it can't be more. The second says Jim also wants more mainsail out than jib. So very simply, that one is just going to be J is less than M. If you wanted to, you could have put M is greater than J. Makes no difference. Okay. So now what we're going to do is figure out how we're going to graph these. So we'll do our boundaries, call them equations. So this one is M equals 80, and the other one is going to be J equals M. So what we can do is we can say that this is our M axis. This over here is going to be our J axis. Now it's not going to matter. It doesn't matter. It's going to work out the same way each way, but we just have to call it something. So since M is X, J is Y, for this one that says M equals 80, it's like we're saying X equals 80. So we're going to have a vertical line that goes through X equals 80. For the other one, J being equal to M, this is like saying Y is equal to X. What we can do is say it has a slope of 1 and a y-intercept of 0. Since X is being multiplied by 1, but there's nothing being added to it, we can say slope is 1 and y-intercept is 0. Pretty easy one to graph. Of course, because we're talking about real numbers, everything is going to be green here. Because this one has equality as a possibility, it's going to be a solid green line. Because this one does not have equality as a possibility, it's going to be a dashed green line. So let's go ahead and set up our graph. We can go 20, 40, 60, 80, 100, good enough. Up here, same thing, 20, 40, 60, 80, and 100. So for the first one, M equals 80, or M is less than or equal to 80. Like I said, it's going to be a vertical line, and it's going to be solid green. We're getting good at this now, so I can move a little quicker as long as I make it. The other one having a slope of 1 and a y-intercept of 0, so we can start right at the origin, 0, 0. It's going to go up 1 and over 1. That means it's going to go up 20 and over 20, or up 100 and over 100, as long as we got equal proportions. So up 20 and 20, 40 and 40, etc. Now this is going to be a dashed green line, so I'm going to try and just make a nice straight dashed green line, looking something like that. Moving fairly quickly here now. For our shading, for this one, M has got to be less than or equal to 80. Anytime you have a vertical or horizontal line, the shading is really easy. M has got to be less than or equal to 80, so clearly we're going to shade everything that's less than 80. that's going to be to the left of that line right there. So we're going to shade left of that one. Do that all at once. For the other one, j being equal to m. So we're going to have to test a point, but we can't test 0, 0 because the line goes right through 0, 0. But why can't we test a point, say 20, 0? 20 on the m-axis, that's this point right here, and 0 on the y. That's just a point that's, we're going to determine whether or not it's in the solution set. So 20, 0, m is 20, j is 0. So we'll put 0 should be less than or equal to 20. Yes, true statement. So for the dashed green line, we're going to shade below. So again, solid green to the left, dashed green below. The region that's going to be shaded twice is this triangular region right in here. Again, if you want to see what the different darknesses, I guess, of shading on your book, in your book on page 316, you see a really nice representation of that. So the question said back at the beginning, what possible combinations of mainsail and jib can Jim have out? It's any point from this region right here. So in the book, they have some points. They say 80 and something around here, 80 and 70. They have another one that's down here that's like 70 and 40. And another one over here that's like 40.5 and 30.75, something like right in there. Okay, these can be any real numbers, so they don't need to be whole numbers. As we progress, we're going to look at testing these points a little bit more, but for now, that's going to be good enough. So any point, any coordinates that are found in the solution region, though, if we were to test those in the inequalities, they should be giving us true statements. And that's going to do it for section 6.3. Please come back to class tomorrow with questions written down. What do you need to know? What are you unsure of? Things of that nature. Come to class tomorrow with lots of questions. We'll go through them, and then you'll have your assignment to work on.